Right, so these are starting to look at acceleration here on page 24 of your booklet. Just a wee quick run through. So acceleration tells you the rate of change of speed. That just means how quickly you can speed up or how quickly you can slow down. So a person, think of a footballer, might have very good acceleration. That means how quickly they can get up to, say, their top speed, but they still might have a slow speed. So acceleration, how quickly you can get up to that top speed or how quickly you can slow down. So there's a formula for that. Final speed, so what you end with, minus your initial speed or your starting speed over how long it takes. And generally I would write the unit like this, meters per second squared, or sometimes you might see this, but I wouldn't worry so much about that. So we'll do a few of the examples that are in your book on page 24. So this one says a car's velocity changes from 20 meters per second to 30 meters per second in 5 seconds. Find the acceleration. So I'd always start by writing down your formula. It's final speed minus my initial speed or my starting speed over time taken, how long it took. So here your final speed was 30 meters per second, your initial speed was 20 meters per second. How long did it take you? 5 seconds. And you throw that into your calculator or work it out. 30 minus 20 is 10. 10 divided by 5 is 2. 2 meters per second squared, because it's 10 meters per second divided by second. That's where you get your second squared. 2 meters per second squared. Another one here. Your initial speed. So say a cyclist went from 6 meters per second. He pulled the brakes and stopped suddenly. He came to a complete stop, and that happened in 2 seconds. So your final speed here, they've asked for the acceleration or deceleration. Final minus initial over time. Your final speed here is what you finished at, which is 0. Your initial speed is what you're starting at over how long? 2 seconds. 0 minus 6 is minus 6. Minus 6 divided by 2 is minus 3 meters per second squared. So that's known as a deceleration. You're slowing down. Another wee one here. Lewis up in Dublin went from 3 meters per second to 10 meters per second in 10 seconds. So if you're looking for this, I just took this from the worked example on page 29 of your booklet. Went from 3 meters per second to 10 meters per second in 10 seconds. So from 3, that's my initial, that's my starting, to 10, that's my final, in 10 seconds, that's the time it took. So they've asked for the acceleration. So again, this is all your workings, you must show them. Final minus initial over time taken. My final speed is 10 meters per second. My initial speed is 3 meters per second. How long did that take? 10 seconds. So 10 minus 3 is 7. 7 over 10 is 0.7. If you're ever unsure, just type it as you see it. And you get 7 tenths or 0.7. And your unit, meter per second squared. You must have your unit. Or say they were chatting about a car and went from 0 to 60. Say we said it went from 0 to 60, we'll say meters per second in 4 seconds. Find the rate of acceleration. You often hear them say 0 to 60 mile an hour, work out the acceleration. Here we'll say we went from 0 to 60 meters per second. Again, anytime they ask you for acceleration, you have to write down your formula over the time. Your final speed from 0 to 60, that's your final, over the time that it took. So 60 divided by 4 is 15. So 15 meters per second squared is your acceleration. You're speeding up. So there's only one there that we seen was a deceleration. You'll have a few more in the questions. And you also just have to draw a distance time graph. What I meant by, just put your time on your x-axis, keep them evenly spaced. There's your 0 there. 1, 2, 3, 4, 5, 6, 7. I drew them all a centimetre apart. And what you're measuring, your dependent variable on your y-axis, and again label it. I think they go up in threes. 9, 12, 15, 18, 21, all evenly spaced, and then you just put a dot and join them up using a ruler. Perfect.